So in the last section, we got one of the most amazing theorems in statistics for quantitative data, which tells us that if we take a random sample of at least 30 and we compute a sample mean, that one sample mean that we compute is actually from a whole family of sample means that follow a normal distribution. Well, this last section in Chapter 6, we get a very similar result for qualitative data when we're looking at percentages instead of means. So all data, no matter what degree field you're in, is either qualitative or quantitative. Now, quantitative can get further broken down into discrete versus continuous, okay, but for the most part of this course, we're just going to worry about whether they're qualitative or quantitative. So in the last section, we learned how to make probability computations and use them to make inferential decisions using quantitative data. And in that section, we looked at the random variable x bar. So we computed a sample mean from the data that was collected. So in this section, we're going to learn how to make probability computations and use them to make inferential decisions using qualitative data. And in this case, we get a new random variable p hat. Okay. So quantitative data. So when we collect some measurement on each object, we have the following random variables. So either we have a random variable x as the measurement of a randomly selected individual. The distribution of x values can have any shape. Some common shapes we looked at were uniform, normal, left skewed, and right skewed. And when you collect a set of sample data, you will have n values of the random variable x. From those n values of x, you compute one value of the random variable x bar. So that was our new random variable we got in the last section, where x bar, the wording for that, is the mean measurement of n randomly selected individuals. And under certain conditions, the distribution of x bar values is well approximated by a normal distribution. So for that, we either need to have a normal population to begin with, or we need to have n at least 30. So those are our certain conditions for this course. Now, qualitative data. So when we have qualitative data, we need to quantify it so that we have numbers to analyze. So when a set of qualitative data is collected, we can either count how many of the individuals are in some category of interest, or we can measure the percentage of individuals that are in some category of interest. So that gives us the following two random variables when looking at qualitative data. So x here is going to count the number of n randomly selected individuals that are in some category of interest. In this case, x can be a whole number between and including 0 and little n. So x can have the values 0, 1, 2, 3 on up to n. Okay, in this case, x is a discrete random variable, and we looked at the binomial distribution for that earlier in this unit. But if instead of looking at the count, the number, if instead we change that to a percentage, we get a new random variable p hat. And so p hat is going to be the percentage of those n randomly selected individuals that are in some category of interest. Now in this case, p hat can be any real number between 0 and 1 inclusive. So as a proportion, it's between 0 and 1. As a percentage, it would be between 0 and 100%. In this case, p hat is not limited to whole numbers, and so it's a continuous random variable. And we will see under certain conditions that p hat also has an approximate normal distribution. So example 6.6.1. So getting some idea of this new sampling distribution that we'll be looking at in this section. So let's assume that 60% of all third graders in the state of Illinois pass the state reading exam. So this is the percentage for all. So that is a value of p. And we're going to take a sample of 10 third graders. So that's our little n. And we're going to count the number who passed. So this is our category of interest. So each of these individuals either passed or failed, and we're picking those who passed to be, that's our category that we're actually interested in counting the number for. So our random variable x here is the number of 10 randomly selected third graders who passed the state reading exam. So again, it wasn't asked for here, but an individual in this case is a randomly selected third grader in Illinois. And the variable was whether they passed or failed the state reading exam. So we've collected qualitative data, so we're going to count the number of these 10 randomly selected third graders who passed the state reading exam. So now this random variable has a binomial distribution because we're counting the number of successes in n trials, where little n is 10, and the percentage of getting a student in the category of interest that they passed, that was given to be 60%. So the probability distribution of this random variable is presented in figure 6.6.1. Okay, so this I got off of StatCrunch using the binomial calculator like we used in an earlier section. So again, we can see that this axis down here runs from 0 up to little n. So if we asked 10 third graders whether they passed or failed, and we counted the number who passed, the smallest that could be is 0, the highest that answer could be is 10. And again, we can see on here we're starting to see kind of a bell-shaped curve. It's got a little skewness to the left. Okay. So in the last chapter, we learned how to compute probabilities for this random variable using the binomial distribution. But now if instead of looking at the proportion or percentages, so instead, I should say, we look at the proportion or percentage of successes instead of the number of successes, we're going to get a new random variable p hat. And under certain conditions, this random variable also has an approximate normal distribution, which means that no matter whether we collect quantitative data and we're looking at x bars, or qualitative data where we're looking at values of p hat, in either case we can use the normal distribution to compute probabilities. So now we have this new random variable. So p hat now is going to be the percentage, instead of the number of, the percentage of 10 randomly selected third graders in Illinois who passed the state reading exam. So once again, just like in the last section, we're going to start by using an applet and StatCrunch, and then we'll summarize the results that we should have noticed from the trends in those graphs. To simulate collecting data from 10 randomly selected third graders and recording whether they passed or failed. Okay, now that's qualitative data. Okay, so the applet's going to use zeros and ones for failures and successes. That doesn't make it quantitative just because it's using numbers. It's just using those to designate which category each child fell into. Okay, so in this context, a 0 will be a third grader who failed the state reading exam, and a 1 is going to be a third grader who passed the state reading exam.